Today's lesson, we'll be talking about section 5.5, inverse trigonometric functions and their graphs. We talked about inverse trig functions in the last chapter, chapter 6, when we were using degrees instead of radians. Here, this is the same thing, so it's kind of a refresher on that, but it will be in radians. So remember that sine and tangent are restricted to the first and the fourth quadrants. So this area and this area. Remember that when you go this way, it's negative. When you go this way, it's positive for these two two trig functions, sine and tangent, because I can't go all the way around to get there, to get to the fourth. So I have to go in a negative direction to get to the fourth quadrant. Cosine is restricted to the second and the first. Here are the restrictions. Okay. So remember, inverse sine can be from -1 to 1, and then the values that it'll output for that, for the range, are from -pi/2 to pi/2. Cosine, you can plug in values from -1 to 1 and get values from 0 to pi. For tangent, you can plug in any real number into the inverse tangent, and you will get values in between, but not including -pi/2 to pi/2, because those values would be undefined for tangent. Okay. Notice also that there's nothing in the third quadrant because of this. Okay. Example 1 says evaluate the following inverses. So if I want to find the inverse sine of 1/2, then I need to figure out which quadrant I'm in, because it's positive. Sine is positive in the first. So I will look there. So I'll have pi/6, pi/4, and pi/3, and pi/2 at my disposal. Pi/6 is the only one that has a value of 1/2. So then that gives me my answer. Okay. Here, most of the stuff is just using your unit circle knowledge. If it's giving you something in radians, more than likely it'll be asking you for something that you can do using the unit circle, so there's not much work to show. Cosine of 0 is at 0. Okay, so inverse cosine of 0 would be the value of 1, because cosine is 1, or sorry, where it's at equal to 0, my bad, is at pi/2, so then that would be my value, or my radian measurement that I should get. I should not get a ratio value at that point. Tangent, or inverse tangent of square root of 3, now here you're in the first or the fourth. It's positive ratio, so you must be in the first. So you have those three values again. It can't be pi/4, because you should have square root of 2/2 somewhere in there, or that'll make 1 for tangent. So if that was the ratio anyway, so it's not pi/4. It could either be pi/6 or pi/3. It's not going to be pi/2, because tangent is undefined at pi/2, and it's not 0, because that would be 0 for tangent. So we can just pick one. So for pi/6, your terminal point is square root of 3/2, comma 1/2. So if I do the ratio there, 1/2 divided by square root of 3/2, and then multiply by the reciprocal, then those cross out, gives me 1 over square root of 3, and if you rationalize, that gives me square root of 3 over 3, so that is not the same as that, so not equal to square root of 3, so then that means that pi/6 is not right, but pi/3 is. So then that would be my answer for the inverse tangent of square root of 3. Now sometimes they'll give you decimals. So the inverse sine of 0.82, I want to first make sure my calculator is in radians, which it is. So inverse sine of 0.82 gives me a value of 0.96. And we can say 1/4 if we wanted. Okay? Make sure that if they're giving this to you, the directions may specify a certain decimal to round to, so make sure you do that. Tangent, or inverse tangent, of 4.9, same thing. It gives me a value of 1.9 0.3695. Okay, so that'll be my answers. Pretty slick on that one. Okay, here sometimes there's compositions of functions. So first find the inside. So sine of pi over 3 would be square root of 3 over 2. Now some of these are just a little redundant because they'll do the double of the same angle. So here now it's asking you the angle or the inverse sine of square root of 3 over 2. So what's the angle that gives you a ratio of square root of 3 over 2 in the first and the fourth quadrant? So that would be pi over 3. Okay? So those ones should be pretty easy because you're plugging in the same thing and getting the same thing out at the end. Okay? Because this is what you're plugging in, and so you're getting it out again. Okay? Now here, tangent or the inverse tangent of cosine of 0, so that's 0 radians. So cosine at 0 radians would be the value of 1. So now you want to figure out where tangent is equal to 1. So it's positive, so it's in the first quadrant. So you have pi over 3, pi over 4, and pi over 6. But the only value that makes sense there is the one that has, because you're dividing, is pi over 4, because you would divide the same number to each other to get a value of 1. For pi over 6, we just found it was square root of 3 over 3, and then pi, that means that pi over 3 would be square root of 3. So then that means those two are not answers. So here, square root of 2 over 2 divided by square root of 2 over 2 would give me the value of the 1 that I'm looking for. So the inverse tangent of -1 would be pi over 4. Okay. Now, something else I would like to just go over real quick. It wasn't one of my examples, but since I got plenty of time, if let's say they give you the inverse cosine of 5/7, and then also say what's the sine of that. Okay. Or how about I switch that actually? The inverse anyway. Okay? Let's say they give you something like that, which is completely possible. Okay? So cosine of 5/7, that means that they want more of an exact value. Okay? So we need to draw a triangle. 5/7 is positive, so it would be in the first for cosine. So 5 is your adjacent side, 7 is your hypotenuse. You'll need to find your y value. So then 5 squared plus y squared equals 7 squared. And so then if I subtract 25 to both sides, gives me 24 square root. I can reduce that a little bit to make it 2 square root of 6. Since I'm in the first, it's a positive 2 square root of 6. So that's my y value. Okay? So now if they want the inverse sine of this angle, okay, they're talking about this angle right here. So really what you just did with the cosine of 5/7 is you found this triangle, okay, of this angle. So you found cosine of, or the alpha that you were looking for. So yay, we found that. Insert that in. So now, oh whoops, my values were correct in the beginning. Okay, because this is a ratio. That's what I wanted to say to begin with. That's actually what I want. So, sorry about that. Okay, so inverse cosine of 5/7 gives you this angle. Yay, we found the angle of alpha. So now sine of alpha would be the ratio that comes from this circle. Okay? Or is this triangle? So now alpha would be the opposite over the hypotenuse for our sine, so 2 square root of 6 over 7. And so that would be the answer. So sorry for the confusion there. So the inverse of cosine of a ratio gives me an angle, and then that angle of that other sine or trig function on the outside wants you to find a ratio, and which would be 2 square root of 6 over 7. Okay, so really we don't care about this alpha because we don't need it. We don't need to know it because we're creating the triangle, which in essence makes the triangle or makes the angle, but we don't need it. It's not a necessity. It's the ratios or the values of the sides of the triangles that's what's important for us. Okay, have fun.